Ah, the chapter on light. You know the one? It's just packed with all these formulas and numericals, and it can feel kind of overwhelming, especially right before a big exam. But what if I told you the difference between a good score and a great score wasn't about memorizing everything? What if it's actually about mastering a few key strategies? Well, that's exactly what we're going to crack today. And this quote right here, it just hits the nail on the head. You can totally understand the concepts, right? But one little misplaced negative sign, one formula you mix up, and boom, the marks are just gone. So our goal today is super simple. Let's make sure all that hard work you've put into understanding this chapter actually pays off on your answer sheet. So here's our game plan. We're going to start with why this chapter is so important for your score. Then we'll break down the formulas for both mirrors and lenses. After that, we'll tackle the most common exam traps people fall into. And finally, we'll put it all together into your ultimate strategy for success. Sound good? Let's get started. Okay, first up, the scoring challenge. Now, in your board exams, there are pretty much two chapters that are famous for having these complex numerical questions: light and electricity. They carry a massive amount of weight, so doing well here is absolutely fundamental to getting a high score in science overall. And take a look at this. What's really interesting here is how the marks are grouped. The unit called natural phenomena, which is where you find light, and effects of current, which is electricity, they're actually bundled together. And combined, they account for a whopping 25 marks. That is a huge chunk of your paper dedicated to these two physics powerhouses. All right, so with that much writing on this, we've got to build a solid foundation. Let's start with mirrors, and the very first essential tool you absolutely need, the mirror formula. So here it is, the mirror formula. At its core, it's just the relationship between where your object is, which is u, where the image shows up, which is v, and the mirror's focal length, f. Now, the formula itself looks simple, but the real secret to making it work every single time is in the signs, the positives and the negatives. They tell you everything you need to know about what's going on. And this is the million-dollar question, isn't it? This is exactly where most marks just disappear. It's not because people forget the formula, but because the sign conventions get all mixed up. So let's make this crystal clear once and for all. Okay, here's the absolute easiest way to remember this. Just picture the mirror's pole as the center, the 0, 0 point on a graph. Anything measured to the left is negative, and anything to the right is positive. Simple, right? So since we always place the object on the left, u is going to be negative. For a concave mirror, the focus is also on the left, so its f is negative. A real image forms on the left, so its v is negative. But a virtual image forms behind the mirror, to the right, so its v is positive. It's that simple. And that brings us to magnification. This formula is awesome because it tells you how big or small the image is compared to the object. And it also shows you why those signs are so important. See that crucial negative sign in minus v over u? If your final answer for magnification, m, is a negative number, you instantly know the image is real and inverted. It's like a built-in check for your answer. Okay, we've got mirrors down. Now let's jump over to lenses and see how this all connects. Lenses follow really similar rules, but there are a few tiny, critical differences that can totally trip you up if you're not paying close attention. And here we have the lens formula. Now look really closely. It looks almost identical to the mirror formula, but see that? It's a minus sign instead of a plus. This is probably one of the most common mistakes students make. They just use the plus from the mirror formula by accident. Just remember, lens has a minus sign. And here it is, the other major trap. Just look at these two magnification formulas side by side. For mirrors, it's m equals times negative v over u. But for lenses, it's just v over u. That tiny little negative sign completely vanishes. Forgetting to drop that sign for lens questions is a guaranteed way to lose easy marks. All right, now for my favorite part. Let's talk about how to avoid those simple, super frustrating mistakes. These are the pro tips that really separate the students who score in the 90s from those who get a perfect 100. Think of this as your pre-calculation checklist, something you run through every single time before you solve a problem. 1. Read the question twice. Seriously, make sure you know what they're giving you and what they're asking for. 2. List your known values. 3. Convert all your units. This is a big one. Get everything into meters unless they say otherwise. 4. Double-check your signs. Go through each value and apply the right convention. And 5. Always show your steps. Even if you mess up the final calculation, showing the right formula and substitution can save you with partial marks.
Okay, so we've got the formulas, we know the traps to avoid. How do we tie this all together into one ultimate strategy? It's all about how you approach your preparation with a clear, confident plan.
So here's the final game plan. Start with NCERT to make sure your concepts are rock solid. Then, you've just got to practice, practice, practice. A great trick to check if you really get it is to try and explain a concept out loud. It might sound silly, but it works. After you practice, analyze your mistakes. Don't just solve a problem and forget it. Figure out why you got it wrong. And finally, revise the formulas regularly. A quick 5-minute glance every day is way more effective than cramming for an hour once a week. And that's it. That's the complete strategy from start to finish. We've gone over the key formulas, the critical differences in signs, and the common traps to look out for. The only thing left to do is to put it into practice. The path to mastering this chapter starts with the very next problem you solve. So, which one are you going to conquer first?